Okay, well, latest offer in from Ben with regard to fake moon landings. All in his head, of course, and in the heads of these other conspirators he's got here. Marcus Allen, famous moon fake spruiker. Now, I think this is quite an interesting comment because Marcus Allen, let's just listen to a little bit of what Marcus Allen has to say.
Now, I don't mind upsetting people. They can criticise what I have to say, and they can point out errors which I make, which I occasionally do, but don't attack me personally. Just attack the information. That is the key point. It's very easy to attack an individual. Oh, that Marcus Allen, he doesn't know what the hell he's talking about. He's ridiculous, stupid man. Don't take any notice of him. That isn't proper criticism. That's not.
Wonder who he could be talking about. I'd stick by what I said previously, and I'll demonstrate it quite clearly that Marcus Allen is clueless. Put a line through Marcus Allen, he's not worth listening to. Now, I did a video, I'm certainly seen it to make a comment like that, where I showed him giving a presentation on Ben's Dreaming Sources conference, if that's the right word, where he says that von Braun and co. were the German scientists that got America to the moon. So, what I would like to ask you, Mr. Allen, is, see, he doesn't address these problems. He doesn't address these things. He just brush over it. You know, don't attack me, attack what I'm saying. Okay, I'm attacking what you're saying. You said von Braun and co. were the German scientists that got America to the moon. Now, if America never went to the moon, how can von Braun and co. possibly be the German scientists that got America to the moon? In fact, at the end of this video, I'm going to include a couple of clips of Marcus Allen saying these things, and you can see for yourself. And he showed, also on Dreaming Sources, he showed an image of Buzz Aldrin and Neil Armstrong in the lunar module. And he said these pictures were obviously taken before they even got to the moon. Now, if they never went to the moon, how could that have been taken before they even got to the moon? He said that twice. Two different pictures. So, perhaps you care to explain that, Mr. Allen. And there's another thing as well. If I can find that one of the regular viewers to my channel, Ben's channel, Bob Branning, sent me an article about Marcus Allen, and I'll see if I can find it and include it in this video. Otherwise, I might do it as a standalone. But apparently, Marcus Allen debated the British Interplanetary Society, and apparently he told them that he did not doubt the historical account. He only doubted the photographic record, not the actual event itself. He believed they went. He thought there was problems with the photographs. Now, apparently that's what he told the British Interplanetary Society. Now, he dodges this question every time I've asked Ben to ask him. I've written comments saying, you know, what is your stance on this? Is it true or false that Marcus Allen told the British Interplanetary Society that he doesn't doubt the historical accuracy of the event? He doesn't doubt that Armstrong and Aldrin stepped on the moon, July the 20th, 1969. He only doubts the photographic record. Perhaps you could clear that up for us, Mr. Allen. That's not attacking you. That's just asking you a simple question. I'll probably be attacking you later on, so stay tuned. And feel free to call me an idiot. I can take it. Now, remember what Marcus Allen has just said. Don't attack what I'm saying. Don't attack me, because that is too easy. And now we'll see Marcus Allen a little bit later in the same video. Okay, this is the same video. Remember, Marcus Allen said, don't attack me, so I don't know what I'm talking about. Attack what I'm saying. And this is Marcus Allen about half an hour further on in the same video.
And then we have that cowboy Elon Musk who says he's going to send tourists to the...
What was that, Marcus? He says he's going to send tourists to Mars. You just call him a cowboy. That's So it's okay for you to go around calling people cowboys, especially people like Elon Musk, who's done quite a lot, I would think, to advance space technology. I've never ever seen rockets landing like they do on Thunderbirds, apart from the ones Musk makes. These Falcons can, the first stage of the Falcon can return to Earth and land. I take my hat off to Elon Musk. I think he's a great man, to be perfectly honest. And you've got Marcus Allen, who seems to be completely clueless with regard most things, calling Mr. Musk a cowboy. And this is after Mr. Allen has said, don't call me names. Just attack what I'm saying. And just point out point out the things that you think I'm saying that are wrong. And of course, when people do, and they are wrong, of course, he completely ignores them. But it's okay. It's okay for Marcus Allen to call people names. We mustn't call him names. We can't say he's an idiot. Don't listen to him. But it's okay to call Elon Musk a cowboy. Hey, Mr. Allen. Okay, next clip. Okay, well, here we have some more pearls of wisdom from Marcus Allen.
You shield it, but they don't seem to be able to do that. And then we have that cowboy Elon Musk who says he's going to send tourists to the moon next year.
Someone's bought a ticket, apparently. Someone's bought a ticket.
Yeah, I started that a little early. Sorry about that. He was actually talking about hardening electronics in spacecraft and saying they don't seem to be able to do that. Well, obviously they do, because the same is true for robot spacecraft. Spacecraft with no crew on board. Curiosity, the rovers that go to Mars. Other deep space probes, they've all got hardened electronics. They're all hardened against all this, sort of solar and cosmic radiation, all that sort of stuff. So they're doing it all the time. Marcus Allen is saying they don't seem to be able to do that. They do it all the time. Do it every day. It's just everyday work for NASA.
Yeah, 60 odd million. Yeah, but it's already, you can say all these things. It's called PR.
Yeah. Are they going to get the money back then if it doesn't?
Yeah, but Musk has launched his own personal Tesla Roadster to Mars. I think it's out beyond Mars at the moment. So he's obviously got a rocket that can send stuff to Mars, hasn't he?
Yeah, exactly.
Well, whether he gets the money back or not, you'll probably not pay it until he's gone. So you pay after his trip. But the point is that Musk hasn't even got a rocket that can launch into space.
Well, of course he has. How many Falcon launches have you seen? He sends rockets in. He sends rockets up to take stuff to the ISS. He launches military satellites, and he launched his Tesla Roadster, which is apparently out beyond Mars. You're not talking about you're not talking about a cardboard rocket stuck in a milk bottle, are you? That's a reasonable launch vehicle.
And to the moon. The last rocket he launched was his car to Mars.
Exactly, and it got there.
It was a great PR stunt, and as he said himself, it looks so fake. He said, amazing what CGI can do these days. Now, he was being ironic, I understand.
Oh, so now that's fake. Everything's fake in the world of Marcus Allen and Ben Emlyn-Jones and these other cronies.
The point is that a lot of that film of this ridiculous car going into space has to be fake, because why didn't the tyres explode?
Has to be fake. Why didn't the tyres explode? You can see the tyres here. Let's assume that they are the actual tyres that were on the car. He just launched his Roadster into space, and he didn't actually put special tyres on it. Now, all they've got to do is, when it's mounted, or before they put it on the crane to load it into the rocket, all they've got to do is drill some holes on the inside wall of the tyre. And then that will equalise the internal and external pressure on the tyre. It's not going to explode, is it? It will still look the same. Tyres are fairly stiff, remember, especially low-profile tyres like this. And of course, it wouldn't show, so aesthetically, it's still going to look the part. But just drilling a few holes on the inside wall of the tyre on the inside would equalise the pressure, internal and external pressure. So the tyre is not going to explode. I would have thought that the temperature might have been more of a concern with rubber tyre than ordinary rubber tyre in space. But perhaps not, because rubber tyres are pretty robust things, on cars. But certainly very, very simple to prevent it from exploding. But it gives you an idea of Marcus Allen's analytical ability. He can't. That would never occur to him. That it would be as simple as drilling or poking a hole in the tyre to prevent it from exploding.
Well, yeah, I mean, it's,
unless they're solid tyres.
Obviously wouldn't occur to Ben either.
Maybe. Made specifically for space vacuums and things. Maybe.
Well, if they let the air out of the tyres, when it was on the launch pad, you'd probably be able to see it. But the point is, if you let the air out of the tyres, you can't let all the air out.
Now, this is Marcus Allen's version of deep thinking. He's thinking seriously about the problem now. you can't let all the air out, because of the ambient air pressure.
When you're on Earth, because you've got 15 pounds a square inch of pressure here on Earth.
And they didn't look flat when it was on the launch pad. I think someone drove.
Well, if you take the weight off them, they're not going to look flat, are they, Ben?
We went up there, I think.
Yes, it was driven up there. But the point is, even if they let the air out, if they then launch it into space where there is an extreme vacuum, we're not talking just a minor vacuum, we're talking about an extreme vacuum, the towers would explode. End of story. But they did.
Yeah, I think this gives a pretty fair example. This is a pretty fair example of how clueless Marcus Allen is. Yeah. He just hasn't got a clue. It just doesn't occur to him. They could just poke a hole in the tyre. It's not going to explode, is it? These guys really. You can see why they never have anybody that knows anything about this stuff on these when they have these get-togethers.
That's interesting.
Can I get in this for a second?
Of course.
Because I want to make.
Oh, here's the chef. He's going to no doubt come up with a sensible comment.
Just a little comment about the electronics, the computer electronics that they have. Orion, which is their latest technology, is using 1987 computer.
Now,
a DX1.
Now, I wonder if he's actually got anything to back that up. I'd be surprised if that's true, because the Orion flight control system is made by Honeywell, and it's based on the Boeing 787 Dreamliner flight control system. And I can't imagine that they would be using technology that old. I mean, normally they would be, if you're introducing a new airliner and a flight control system, or a new spacecraft and a flight control system, you're going to use components that are going to be available for the life of the airliner. Something like that has been around since 1987, could probably disappear overnight, and then how are you going to support your brand new product? So personally, I don't believe that. That does not sound logical to me. I don't know as fact that he's talking rubbish, but having seen the rest of this presentation, I would say that it's more likely to be rubbish than not. But he doesn't offer any evidence to back up this statement. Okay, next. This is quite funny. This is where they're talking about, you can't get in and out of the LEM with the space suits and all this sort of stuff. And there's a new design for this lunar rover or Mars rover, where the astronaut sort of steps in the suit from inside of the vehicle. Steps into the suit, and they butt the suit back up here. Of course, you've still got to worry about pressure sealing all this. But the bit that I thought was funny was this comment.
And we're rethinking their whole approach to possibly, if they did go to the moon officially.
If they did go to the moon officially, well, I think if you ask NASA and the American government and the scientific community, I think you'll find that they have officially been to the moon. If they did go to the moon, if they did go to the moon officially, I don't know where on earth do these people come from, really? And here we have Marcus Allen talking about live broadcasts from the moon.
Would see it. We were all watching it, weren't we? On the front, crouched in front of our TVs at 3 o'clock in the morning. My mum and dad were. They told
Yes, I was.
me all about it. So that would be very, very.
Well, yes, in fact, you mentioned a very interesting phrase there. Live TV. Live TV from the moon. They even flashed it up. You see the old film, Live from the Moon. Any radio or television engineer will tell you the sort of power that is required to transmit a television picture. And it's measured in kilowatts, several, even tens of kilowatts. So how much power was carried on the Apollo spacecraft which transmitted these famous TV images from the moon?
Well, their antenna looked not much bigger than the kind of thing you used to see on the side of blocks of flats and things like that.
Exactly. And that was supposed to be pointing generally at the Earth. So how much power would be required to transmit through it? Now, the maximum power available on the Apollo spacecraft, and in fact, Scott can actually confirm this by the research he's done, is in the order of 4 kilowatts.
Okay, so that's the power available on the lunar module at any given time was, I believe, a peak. Peak was 4 kilowatts. So yeah, that's right. But again, Marcus Allen is showing his complete lack of understanding with regard broadcasting, communications, links, and all that sort of stuff. It's true to say that if you're broadcasting a television signal to lots of houses, you need lots of power, tens of kilowatts, hundreds of kilowatts. I think Crystal Palace was a megawatt ERP, effective radiated power. It doesn't mean the transmitter puts out 1,000,000 watts, of course, because there's a thing called antenna gain, and I'll show you what that's all about. So, how much power was the lunar module actually transmitting? Now, it was S-band, of course, so it's a microwave link back to the Earth. And the amount of power they used was either 1.3 or 2.2 kilowatts, I think, the actual effective radiated power. And although that's less than his 4 kilowatt peak battery power, the amount of power, RF power, fed into the antenna was only 20 watts, because there's something called antenna gain. These guys have no understanding of radio engineering, antenna gain, or anything like that. Now, for the transmitter, the S-band transmitter, to produce 20 watts, it's probably 50% efficient. That's probably being generous back in those days. So let's say there's 40 watts being taken out of the battery to generate the 20 watt S-band signal, which is then fed to the dish, and because of something called antenna gain, the effective radiated power from that dish antenna was either 1.3 or 2.2 kilowatts, depending on which measurement you want to use, because there's two measurements, and I'll show you those in a second. But first, let's just have a quick look at the lunar module. See what NASA say about the lunar module communication system. Okay, so again, a little bit of Googling, and here is a NASA document that tells us all we need to know about the lunar module communication system. Remember, it's not a broadcasting system, it's a communication system. The 2.28 gig link is a microwave link back to the Earth. It's not it doesn't broadcast a big omnidirectional radiation pattern, so you don't need hundreds of thousands of watts. Okay, so it says all S-band transmissions are at 2,282.5 megahertz. Rather than using travelling wave tubes for S-band power amplification, as does the CSN, that's the Command and Service Module, the lunar module uses amplitrons, which provide 20 watts of RF power. Now, an amplitron is a microwave power amplifier. It's a valve, it's a thermionic device, Difference between those and travelling wave tubes is that they are a narrower bandwidth, but they are more efficient. So, you know, if you don't need heaps of bandwidth, if you can get the bandwidth that you want with these devices, then it's far better to use one of these, especially if you've got limited battery power. So if it's generating 20 watts of RF power, it's probably pulling, you know, at least twice that out of the battery. So 40 watts, so 50 watts out of the battery would be the power consumption of this thing. This 20 watts of RF power, maybe more, maybe 100 watts. I mean, it's 1969, might not have been very efficient at all. Certainly wouldn't be kilowatts that they're pulling out of the battery. Now, it achieves the energy required to produce a signal big enough to reach the Earth by using something called antenna gain. Now, because Ben and Marcus Allen and these other guys here aren't radio engineers, they don't understand any of this stuff. They know nothing about broadcasting, they know nothing about communications links, they know nothing about antenna gain. They've probably never even heard of it. But antenna gain is, I'll show you what the antenna gain will do for this 20 watt signal. And it says the lunar module is equipped with 4 S-band antenna elements. One of these, the steerable antenna, is high gain antenna used to maintain line of sight communications between the lunar module and the Earth. Okay, so they found that this steerable antenna on the lunar module, the signal from it was so good they didn't need to deploy the erectable antenna, which is bigger, higher gain, would have given them a bigger signal. They thought the signal from the steerable antenna was adequate. Now, they're saying the antenna is 26 inches in diameter. 26 inches in diameter. There we go. So as Ben says, it's the sort of thing you'd see stuck on the side of a house. It has a transmit gain of 20.5 decibels. Transmit gain of 20.5 decibels. Okay, so let's just use those figures, 20 watts of RF power, and the transmit gain, that's the antenna gain, of 20.5 decibels on a power calculator. And let's just see what that gives us. Okay, so here we have our pure ERP and EIRP calculator, again because Ben and co know absolutely nothing about this sort of thing, radio engineering. That would be meaningless to them. ERP is effective radiated power and EIRP is effective isotropic radiated power. Okay, so let's go down to the calculator. Actual transmitter power output. Now that was 20 watts, wasn't it? And our antenna gain was 20.5 dB. They probably didn't use dBi back then. And we'll calculate. And let's look at our results. Calculated results, here we go. 2,244 watts, rounded 2,244, effective isotropic radiated power, 3,680, rounded 3,680.221, so 3.6 kilowatts. So back in the days of Apollo, they wouldn't have been calculating the isotropic radiated power. It would have been the lower figure, the ERP, and that would have been 2,244.037 watts. So 2.2 kilowatts was the actual amount of radiated power they got from their 26-inch S-band antenna. And because it's a link, because it's a narrow beam going from the moon to the Earth, they don't need to radiate this colossal omnidirectional signal to lots of little televisions all over the moon. They can concentrate all the energy into a narrow little beam. They only need a couple of kilowatts to get that signal back to the Earth. And that's how that works. And remember, all this time it's only taking probably between 50 and 100 watts out of the battery on the lunar module. Okay, next clip. Okay, well, here we have Marcus Allen again, and he's going to show us how little he knows about amateur radio operators.
The Russians, with the full knowledge of the British and American government.
I've started it just slightly early, sorry about that. He's talking about tracking the vehicle. I might do another clip, a separate clip about that one a little bit later on. But that clearly demonstrates that he knows absolutely nothing whatsoever about how telemetry systems and communication systems work. Anyway, let's proceed.
There's no problem about that. And then we get on this ridiculous story of the ham radio operators who were listening in to the Apollo command module.
That's another one I heard.
How are they listening when the command module and the lunar module, well, the command module specifically, were transmitting back to Earth, we're told, using the gigahertz frequency?
And with
I think he means a microwave frequency. Yeah, that's partially right. They used an S-band 2.2 gigahertz, 2,200 megahertz. Link back to the Earth from the command and service module, but what the radio amateurs were listening to was the high band VHF. It wasn't quite UHF, it was UHF starts at 300 megahertz. I think it was about 280 megahertz. So high band VHF communications between the command module and the lunar module. That's what they were listening to.
Only was it 4.5 kilowatts?
Yes, and ham radio operators can only operate on long wave.
Mr. Allen showing us his complete ignorance with regard to where amateur radio operators can actually operate. Amateur ham radio operators can only operate on long wave.
Oh, gigahertz. They don't have the equipment to do it.
Okay, let's just listen to that again. What's that, 150.20? Okay, let's go back to 150. Oh, sorry about this. Let's go back to there and hear it again.
Which is what they were employed to do by the Russians with the full knowledge of the British and American governments. But there's no problem about that. And then we get on this ridiculous story of the ham radio operators who were listening in to the Apollo command module.
That's another one I heard.
How are they listening when the command module and the lunar module, well, the command module specifically, were transmitting back to Earth, we're told, using the gigahertz frequency?
And with only was it 4.5 kilowatts?
Yes, and ham radio operators can only operate on long wave. Gigahertz. They don't have the equipment to do it. Again, another fan.
Yeah, and again, Mr. Allen is talking absolute rubbish. Let's just have a look at the amateur radio allocations, shall we? In America, it was an American guy that was actually doing that. His name was Larry Basinger. He's actually still alive, Larry Basinger. His call sign W4EJA, and he was listening to the VHF communications using a rather large horn antenna he made, and a modified military receiver, I think it was. But you can read all about that, and I might leave a link to that below. In fact, I probably will. But first of all, let's just have a quick look at the amateur band allocations in America. Okay, so we start off here, 2,200 metres, that's 135 kilohertz. That's long wave, yeah. 472 kilohertz, yes, that's long wave as well, 630 metres. Then we go to 160 metres, that's more a medium frequency. 80 metres, it's 3.5 megahertz, that's a high frequency, of course. Then we go to 5.3. Then it will go. There's quite a lot of radio spectrum allocated to amateur radio operators. You got a 60 metre band. What you got here? 40 metres. Where's that? 40 metres. 7 megahertz band. 10 megahertz band. 14 megahertz band. Most of amateur radio operating is done on the short wave bands. These are the short wave bands, 14 megahertz, 20 meters, 30 meters, 17 meters, 21 megs. We're getting higher and higher. We're going up to 24 megahertz here. We go to the top of the next. 28 megahertz. Ooh, getting higher still, 50 megahertz, 144 megahertz. Certainly these are nowhere near long wave. 222 megahertz, 420 megahertz, 902 megahertz, 1240 megahertz. That's 1.2 gigahertz. And if we look down here, I haven't bothered putting the rest of the band plan in there, but we can see that there are also allocations at 2300 to 2310 megahertz. That's 2.3 to 2.31 gigahertz. That's the first one. The first one here. Now Apollo was 2,280 megahertz, I think, so slightly lower in frequency than the this particular amateur radio band. They got 2,390, so that's 2.3 gigahertz, 3.3 gigahertz, 5.6 gigahertz, 10 gigahertz, 24 gigahertz, 47 gigahertz, 76 gigahertz, 122 gigahertz, 134 gigahertz, 241 gigahertz, 241 to 250 gigahertz. So Marcus Allen saying that amateur radio operators only operate on long wave is talking out of his backside. In fact, the more I listen to Mr. Allen, the more I think he should get some thinner underpants, because so we can understand what he's saying more clearly, because he's perpetually talking out of his backside. Okay, so that's that, and I did actually have I had a video of an amateur radio operator bouncing a signal off the moon with some very modest equipment that I might actually show you. In fact, I think I will. So I'll stop this clip here, and then I'll go to the clip of the amateur radio operator. Okay, so here's a very short clip, and I'll leave a link to this below as well. This is an amateur radio operator, and he's using some very modest equipment to do a 10 gigahertz. Remember, Marcus Allen said the radio amateurs can't operate in the gigahertz, they don't have the equipment. 10 gigahertz EME, that means Earth, Moon, Earth, SSB echo test. Now what that means is, Earth, Moon, Earth means he's going to generate a signal with his radio here. It'll go to a little dish outside, goes up to the moon, and bounces back from the moon and back to the radio. Now, don't worry about these frequencies indicated on his radio here, because this radio is connected to a transverter. Transverter is a transmit-receive converter, so it's converting the 28 megahertz to 10 gigahertz. And let's just have a quick look at this.
One, two, three. 1, 2, 3. Moon. Testing. 1, 2, 3. 1, 2, 3. 1, 2, 3.
Well, there you go. There you go. I think you get the gist of that. So that's not listening to a signal that's being generated on the moon. This is a signal being generated on Earth. It's being fired up at the moon. It's coming back from the moon, and he's hearing it. And the delay, of course, is because the moon is so far away. 250,000 miles, you've got 500,000 mile round trip. Radio signal travels at the speed of light. So the delay is about, a second or whatever it is. It takes for the signal to go from the Earth to the moon and come back again. So there's a very, very simple demonstration of an amateur radio operator using equipment in the 10 gigahertz band, many more gigahertz than Apollo was using, just bouncing a signal off the moon. Now, it's important to remember too that the guy wasn't actually listening to the 2.2 gigahertz link from the Apollo mission, either the lunar module or the command module, because that would have been sort of encrypted, or it would have had a modulation scheme that he wouldn't have been able to demodulate. He was listening to the VHF, high band VHF analog AM communications. That's what he was listening to. So there we go. So that's just an example there of an amateur radio operator using equipment to bounce a signal off the moon, and using a gigahertz, 10 gigahertz frequency, a frequency within the 10 gigahertz band. Okay, let's see what we can find next. Apologise in advance for the sound here. All the crackling noise is actually on Ben's original video. But here again, these people he's got on his panel are demonstrating their complete ignorance with regard to the way these things work. Okay, let's have another giggle.
The craft on the way to the moon, so for example, Jodrell Bank telescope claims to have followed the command module all the way to the moon and the lunar surface.
Radio communication?
By but apparently he's accepting the radio transmission as well.
I've never seen a radio that can GPS locate where the signal's coming from.
He's never seen a radio that can GPS locate where a signal's coming from. Well, a couple of things to consider here. First of all, they were operating well outside of a constellation of GPS satellites. The other thing, which is smack in the face obvious, is that there were no GPS satellites in 1969. And following a spacecraft using its acquisition beacon, or its telemetry, because remember there's a constant link back to Earth showing all the temperatures, bus voltages, and all this sort of stuff. This telemetry link on S-band, Jodrell Bank would very easily be able to track that. The other thing too is that when the lunar module was actually going to go in and land on the moon, Marcus Allen says at one point, no radar is going to be able to track a 20-foot diameter vehicle going down to the moon. And of course, what he misses completely is that the telemetry from the lunar module is going back to the Earth. So what they're reading on Earth is the instrumentation on the lunar module from the through the telemetry link. So it's got its radio altimeter and all this sort of stuff, and all the instrumentation of the lunar module is showing the speed, the pitch, and the altitude. All this sort of stuff is being given to the astronauts. So it's just like landing a plane. They're landing the lunar module, and that link is going back to Earth, and back on Earth they're seeing all that information. They know it's 20 feet off the ground, or they know it's 200 feet off the ground, and they know its lateral motion is X amount of miles per hour. Marcus Allen is completely clueless in this regard. He has no understanding whatsoever of any of these systems, and neither of these other guys. They're just clueless. This whole video is a complete waste of time. In fact, I honestly don't know why I'm wasting my time on it. The comments are beyond ridiculous. If you think about in the Second World War, you got the people operating behind enemy lines, and they'll get their suitcase radio out, and they'll make their broadcast as quickly as possible because their signal can be, their position can be pinpointed by people trying to find them. As soon as you turn a radio transmitter on, someone can find you. They can find exactly where that transmitter is. And this guy's just talking out of his backside. He doesn't know how anyone can locate a radio transmitter. It's just ridiculous. If you go up on the roof and you're putting a TV antenna up, and the wife is shouting at you, no, it's snowy, and no, it's okay, it's snowy again, and you end up getting the optimum position because you're pointing the antenna directly at the television transmitter. Television transmitter might not be far enough away, but you can draw a straight line along the boom of that antenna, and it's going to go through that television transmitter site. And if you go a few miles in another direction and you still have another television transmitter and that's pointing at it as well, and you draw the two lines on the map where they cross is where the television transmitter is. You can do the same thing with radio telescopes on Earth. And you got to I mean, yeah, it's just it's beyond ridiculous, absolutely beyond ridiculous. I've got to use one hand to hold the camera. I don't think I could even draw it on a bit of paper, but yeah, I probably should have thought about that earlier, shouldn't I? But you've got your big dish antenna, and of course it's only going to receive a signal when it's in one particular position. And you know that when you're receiving that signal, your dish antenna is pointing directly at the spacecraft. You know what the angle is, and if you know the angle and you know where you are on the Earth, you can work out using math where the other side of the triangle is, and you can tell exactly how far the spacecraft is from Earth. These people are just bloody clueless, absolutely clueless. Okay, if I can be bothered. Oh, actually, no, because there's going to be a watch. I'm going to put this in before the watch. There's a bit on the moon watch, and I might finish with that because I'm getting pretty weary of this. There are no anomalies in any of their photographs. When they're talking about, Buzz Aldrin coming out of the back of the lunar module, and he's lit. Just think about it. If you live in a country where in the winter you get good snow coverage on the ground. Now, I haven't seen snow for decades, because where I live in Australia, we don't get snow. Even in the winter, it doesn't get down to 0 degrees. So, but when I lived back in the UK, and there'd be thick snow on the ground. Okay, just picture this: thick snow on the ground. You're out in the country. There's no street lighting, but there's a full moon. Think how much light there is. Now that's not. That's light coming from the sun's reflecting off the moon's surface, and it's coming another 250,000 miles back to you, reflecting off the snow. And I can remember thinking, at midnight in London, or just outside of London in Essex, with a full moon, snow-covered ground, how bright it was, and commenting that it was almost like daylight. It was certainly good enough to illuminate things. So. Yeah, these people are just completely clueless. I've had enough of this absolute rubbish, so I'm going to end with just a clip of the Moonwatch. Oh, and after the clip of the Moonwatch, I think I'll just put a couple of clips of Marcus Allen. Marcus Allen's Freudian slips showing that beyond any doubt that he knows the Apollo moon landing happened exactly as the history books tell us. Question for Marcus Allen, of course, is why persist in this fake moon landing rubbish? Right, now here we have the the Brains Trust. I've said it before or later or both, discussing the Moonwatch.
This one is quite interesting because, of course, the watch says 11:15.
The watch says 11:15. Okay, let's just expand this a bit. I know I should use video capture software, but I really can't be bothered. Certainly not with a video like this. Okay, now what he's suggesting is that this has to be fake because Buzz Aldrin or Neil Armstrong, whichever one it was, stepped on the moon at a certain time. They quote a certain time for that activity, and it has to be faked because here's a view of the Moonwatch, and it's showing a completely different time. This, of course, is beyond nonsense. It's just. I have to wonder, how dumb somebody would have to be to even think along these lines. It doesn't say this watch is the watch that's worn on the arm of the astronaut at the time, does it? This is just a stock picture of an Omega Speedmaster that's just put on there to show what the watch looks like. The time is completely irrelevant. And the other thing too that I've just noticed is you got a subdial there at 9 o'clock, you got a subdial there at 3 o'clock, and there is no subdial at 6 o'clock. The Omega Moonwatch has a third subdial at 6 o'clock. So not only is this not the watch they were wearing at the time, this is not even the correct model. It's a variant of it's a much later variant of the moon watch. So you can forget any comments. Any of these comments about the time shown on the watch are just completely irrelevant. It's absolute rubbish. Okay, well, let's just press play. I don't know how much I can stomach of this twaddle, but here we go.
Now, Buzz Aldrin descended officially to the lunar surface at 3:16:15 UTC time. This photograph was taken 59 minutes and 20 seconds after he descended onto the lunar surface. So UTC time, it should say 4:15.
Why on earth someone would focus on that, on a stock picture of an Omega Speedmaster, and say the moon landing was faked because this is showing a different time? I mean, can you imagine? You would have to be as dumb as a box of hammers to go down this path of argument. It's nonsense.
Okay, but what it's saying is 11:15. Even if you were in Florida time, that would be wrong. It might be correct. Well, who knows when they shot it, because it's a simulation, right? Whatever the time.
Yeah, I think his IQ is a simulation. No one could. No one could really be that stupid. I think. I think he has to simulate being that stupid just to get onto Ben's YouTube channel.
Time they're supposed to be shooting at. He's shooting at whatever the local time is, and that could be Houston or Arizona.
I wonder what the local time is on the moon. How many hours ahead is it?
And what's the make of the watch? I mean, is it a particular brand?
Oh yes, it's Omega is the brand of watch.
Omega, yeah. Well, you can still buy that watch today for about $25,000.
Again, it's more drivel. Demonstrates extremely poor research. 5 seconds worth of googling will show that you that you can buy the Omega Speedmaster Professional Moonwatch for about $5,800 American, nowhere near $25,000.
But I've not seen it. I've not seen them advertise the fact that their watch went to the moon. I mean, you'd think that their brand.
You just go on.
Ben hasn't seen them advertise the fact that their watch went to the moon. Yeah, okay. Well, again, that is something that's extremely difficult to miss. The Omega Speedmaster Professional is probably the second most iconic watch on the face of the planet. Second only to the Rolex Submariner. And that will be a bit of a bone of contention, of course, amongst watch buffs, but I think most people would say that the Rolex Submariner is the most iconic watch in the world, and the second most iconic watch in the world would be the Omega Speedmaster Professional as worn on the moon. And it may be the other way round. You know, a lot of people would argue that the Speedmaster is the most iconic watch and the Rolex Submariner is second. And there might be one or two others thrown into the pot for good measure by watch buffs. But as far as the general public is concerned, if you Google most iconic watch in the world, it will probably come up Rolex Submariner. And if you Google second most iconic watch in the world, it will probably come up Omega Speedmaster. So, in fact, I'll show you. I'll do another clip and I'll show you how easy it is to get information on the Omega Speedmaster Moonwatch.
On the Omega website.
Oh, they do.
Buy that watch today. Again, the lunar watch is actually one of their cheaper models. They have much more expensive models than $25,000 ones.
Again, you know, repeating the $25,000. This guy is clueless. $5,800, and you could be the proud owner of such a watch.
Wouldn't that be lubricated slightly with some minor mechanical oils or something? Or a watch?
I have no idea what they would put in a watch.
And the temperature variation, again, you have like the very hot conditions in the sunlight and extremely cold conditions in the shadow. Could a watch like that handle that? Well, I'm going to include a clip
A couple of clips here about the watch. There'll be this one following from the Omega watch company's website, and then another one showing the range of tests that a number of watches from different manufacturers had to go through to be selected as the watch worn on the moon. They didn't just go down the road and say, well, that's a pretty watch, that looked great on a spacesuit, we'll buy half a dozen of those. I don't know where Ben just doesn't seem to think. He seems to have zero analytical ability. He just doesn't think about things. Does he really think NASA would just go out and buy some watches and stick them on spacesuits? All these watches had to be thoroughly tested through a whole range of these parameters, you know, high temperature, low temperature, pressure, all this sort of stuff. I'll show you a list of tests that they actually put these watches through just a little bit further on.
Watch like that actually function in that kind of environment?
Yeah.
Because it's very delicate clockwork, you know, it's like little springs and cogs and gears and things.
That's right, yeah.
Any metallic expansion, you know what it's like.
The battery would keep it running?
Oh, yeah.
Again, there's the genius. I don't know if that guy's the chef or not, but he's saying, would the battery keep it running? No battery in an Omega Speedmaster, of course. It's a hand-wound mechanical chronograph. Doesn't have a battery in it.
I went to Canada in 97, I think it was, and I took my SLR camera and it was just failing, and that was kind of minus 10 degrees, I think. And
Yeah, they don't like the batteries or those sorts of things.
yeah, it was just failing, like the shutter mechanism wasn't working properly. Went back into the warmth and it started working again. So we're meant to believe that a watch like this, an intricate watch, is supposed to operate in huge temperature differences.
And again, just take a look at the range of tests in the following clip. These people are beyond clueless. They really are. They just don't consider that people test a watch like that for space missions and being worn in a vacuum and in different temperatures and all that sort of stuff. By the way, the Omega Speedmaster Professional is still space rated. NASA still use it.
The battery, when the liquid leaks out of it, it quits working, right?
Yeah.
To be honest, there's no point continuing on with that because they're talking about batteries, and of course it's a mechanical watch, there's no batteries in it. Okay, but that might give you some idea as to how clueless these people actually are. Okay, let's go to the next clip and we'll see the Omega Moon Watch with the extra dial, the actual one that was worn on the moon. Okay, so here we are. We're on the OmegaWatches.com website, and there is the Speedmaster Professional. Now, as we can see, let's just go look at the blurb here. It says the Omega Speedmaster Professional Moonwatch is one of Omega's most iconic timepieces, having been part of all 6 lunar missions. The legendary Speedmaster is an impressive present representation of the brand's adventurous, pioneering spirit. Okay, so let's have a look at the watch. It's got a sub-dial at 6 o'clock. And if you actually look at the specifications for the watch in the next clip, I don't actually point it out unless I redo that clip, but it will say that it has to have 3 sub-dials. It's got to be able to measure this, it's got to be able to measure this, it's got to be able to measure this, so the 3rd sub-dial would have been required. So that picture was a stock picture of a later Speedmaster. The later Speedmasters only have the 2 sub-dials, here, and they also have the new coaxial mechanical automatically wound movement. They have sapphire glass, whereas the original one doesn't have sapphire glass because the covering had to be shatterproof. This is Hesselite plastic sort of stuff, and is hand wound. So there you go. There is the Omega Moonwatch on the Omega website. And you can go to any Omega dealer. Certainly if you go to eBay, go on the internet, there's lots of people selling these brand new in boxes with warranties and tags and everything else for less than $6,000 US. So there's the Omega Moonwatch, and Ben's never heard of it. He must have been living under a rock probably for the last 30 or 40 years. But there it is. So I think you can dismiss anything those guys had to say about the moon watch. Doesn't have a battery. The time shown on the dial was just a stock photograph. It wasn't even the correct model. Here's the correct model, so you can forget all about that, you know. Supposedly showing the time being different to the time that Buzz Aldrin stepped on the moon. It's just so far beyond nonsense. It's really, I'm struggling to bring myself to comment on it. It's just so ludicrous. Okay, well let's take a look at the tests and specifications. And again, all I did was Google NASA Moonwatch tests, and straight away this has come up. NASA testing regime for the Omega Speedmaster Moonwatch. Basically what they did was a couple of the it said, how did the Omega Speedmaster become the Moonwatch? The crowning of the Moonwatch started with a suggested list of manufacturers and a statement of specification coordinated by NASA astronaut Donald K. Deke Slayton and NASA engineer James H. Reagan. Okay, so, you know, Ben and Co seem to think, oh, they just got these Omega watches and they just slapped them on. This wouldn't work, that wouldn't work, you know. It doesn't occur to those people. They're just not smart enough to even consider NASA would thoroughly test a number of watches from different manufacturers to see which was the best one to operate in that hostile environment. We have here, and of course that's what they do, suggested list of manufacturers: Elgin, Benrus, Hamilton, Meadow, Lucien Picard, Omega Boulevard, Rolex, Longines and Gruen. But Rolex were really disappointed at not being picked. And then we have a statement of specifications with regard to accuracy, pressure integrity, readability. There we are, high temperature test. And this is a list of all the tests they did. How long they exposed the watch to the different temperatures. High temperature, low temperature. In the pressure chamber, you know, how much pressure, how much vacuum, how much humidity, how much pure oxygen in the atmosphere. Shock resistance, number 6. 6 shocks of 40 Gs each in 6 different directions, with each shock lasting 11 milliseconds. Look at these specifications. These are engineering specifications, you know. Ben and these other guys are not engineers, they're not scientists, they're completely bloody clueless. Acceleration. It should be accelerated linearly from 1 G to 7.25 G within 333 seconds, along an axis parallel to the longitudinal spacecraft axis. These are all tests done on these watches to see which one was the most robust. High pressure should be subjected to a pressure of 23.5 psi for a minimum period of an hour. Vibration, 3 cycles of 30 minutes, lateral, horizontal, vertical, frequency varying to 5 to 2,000 cycles per second and back to 5 cycles per second in 15 minutes. You know, they're shaking, rattling and rolling these watches. Acoustic noise, minus 130 dB, over a frequency range from 40 to 10 kilohertz, 40 hertz to 10 kilohertz, for a duration of 30 minutes. You know, they didn't just think, well, that's a pretty looking watch, we'll buy those. There's a whole list of all these tests that it had to go through in order to be selected to be worn on the moon. And Omega was better than Rolex and all those other manufacturers. That was why they went with the Omega Speedmaster. So, you know, these guys are really not worth watching. To be honest with you, I'm surprised I'm giving this video as much of my time as I am, because it really doesn't deserve it. And take my word for it, it really doesn't deserve any of your time either. It's just 4 hours of absolute rubbish. Okay, let's go on to the next clip. Okay, Marcus Allen's Freudian slips. Now, this is from Ben's Dreaming Sources presentation. This is actually from a video I did debunking it, but this is a trailer for the debunking video, but you see there's Buzz Aldrin and there's Neil Armstrong. They're in the lunar module. And Marcus Allen is going to tell us that he's unhappy with that picture. And there the reasons that he's unhappy with the picture are irrelevant, but the comment he makes, I think, says it all, really. And the comment he makes is, this picture was taken before they even got to the moon. So let's hear Mr. Allen saying those words, before they even got to the moon. Well, if they never went to the moon, Mr. Allen, how could this picture have been taken before they even got to the moon? Okay, let's see Mr. Allen telling us that he thinks this picture was taken before they even got to the moon. So let's hear what Mr. Allen has to say about that picture.
You also have a highlight there, which is the same thing. So this was taken under controlled conditions in the simulation rig before they even went to the moon.
That picture was taken under control conditions in the simulation rig before they even went to the moon. So if they never went to the moon, how could that picture have been taken before they even went to the moon, Mr. Allen? Perhaps you could tell us all the answer to that one. Okay, and the next Freudian slip. And again, here's Marcus Allen from Dreaming Sources. This time he's telling us all about Werner von Braun and the German rocket scientist that went to America after the war.
Scientists reported into America and immediately the paper clipped onto their visa application, saying that they were good people and they weren't Nazis. They were Nazis. Werner von Braun was a major in the SS. They were all Germans who got America to the moon.
They were all Germans that got America to the moon, eh, Mr. Allen? Your subconscious is telling us all that you know that America went to the moon. You know Buzz Aldrin and Neil Armstrong stepped on the moon on July the 20th, 1969, just like the rest of us do. It keeps you on the talk circuit, though, all this rubbish, doesn't it? So he's talking about Werner von Braun and the rocket scientists that went to America after the end of the Second World War. Part of Operation Paperclip. They just changed their CVs to say they were good guys, they weren't really Nazis, and this enabled them to work on the American space program. Not the American movie industry, notice, the American space program. And in the words of Mr. Allen, they were the Germans that got America to the moon. Perhaps you could explain to us, Mr. Allen, if it was all faked and the Americans never went to the moon, why exactly you think that von Braun and co. are the Germans that got America to the moon. Okay, I think there's another one, but if there's not, I'll catch you next time. Okay, yes, I thought there was another one, and here it is. Might be worth a look.
It's a very weird situation.
There's nothing weird about any of this. The weirdness is in his head.
Anyway, here are our heroes.
This is another picture.
Top one is Orion.
This is not the picture I showed you earlier with the two guys in the lem. This is a different picture.
Neil Armstrong. And I put it in that format because this was taken from a book bought at the Cable Spacecraft, but a NASA publication, and it reads, Astronaut Edwin Aldrin inside the lunar module after his moonwalk. That is a lie. If you find the original of that photograph, it was taken before they even reached the moon.
That picture was taken before they even reached the moon. There's Mr. Marcus Allen saying that picture was taken before they even reached the moon. Well, perhaps, Mr. Allen, you could explain to us all If it's all faked, they never went to the moon, why you would make a comment like that? Why would you say that photo was taken before they even reached the moon? Okay, well that's just to end the video there with the three very obvious Freudian slips made by Marcus Allen. I think it shows us all quite clearly that he knows very well that the moon landing happened, exactly as the history books tell us, why he persists in spruiking all this fake moon landing nonsense. My guess is that gives him something to do, keeps him on the talk circuit, might make him a few quid. What is extremely difficult to miss, what is painfully obvious, is that he doesn't believe his own presentation. He knows he's talking rubbish. Okay, well, I think that will do. That's as much as I can stomach of the fake moon landing mob for today. Perhaps I'll catch you again, depending on how bored I get over Christmas. And if not, I'll catch you when I catch you. As always, if you struggled through the video all the way through to this point, jolly well done. Many thanks for watching, and I might catch you again.